Okay, we had gone some little bit discussion on the same, but now because of I want to reinforce it, so I want to do more discussion on that. First of all, organic, these are, okay, what comes to your mind is that materials have already decomposed. So organic chemistry is the study of hydrocarbons. That's what we have said while in school. Hydrocarbons. Hydrocarbons is, okay, organic chemistry is the study of hydrocarbons. Hydrocarbons are compounds made up of hydrogen and carbon only. Hydrocarbons are compounds made up of carbon and hydrogen only. So these hydrocarbons are classified into three groups. They are classified into three groups. We have these groups include, we have alkane, we have alkene, and we have alkyne. All are the groups of hydrocarbons. They are groups of hydrocarbons. They are made up of carbon and hydrogen only. So I want to start with alkane. Alkanes are compounds that are linked by a single covalent bond. They are compounds that are linked by a single covalent bond. Okay, I want to talk more about carbon itself. In Form 2, you studied about carbon. It has got 4 valence electrons. It has got 4 valence electrons. These 4 valence electrons, because it loses 4 to attain positive charge, that is 4 positive. Therefore, the valence electrons are equivalent to the number of bonds it makes with hydrogen atoms. So if you see carbon alternated by 4 indicates the bonds that it links, it makes with that. So this alkane, we say it is saturated hydrocarbon. Saturated hydrocarbon. That contains maximum number of hydrogen atoms, possibly bonded to carbon atoms. Hydrocarbons is the compounds containing maximum number of hydrogen. What I mean by saying maximum, if you check on carbon, it is linked by it has got it is surrounded by 4 bonds. It is surrounded by 4 bonds. So those bonds surrounding carbon are linked to hydrogen atoms. So one bond is linked to hydrogen atom, another one to hydrogen atom, another one to hydrogen atom, another one to hydrogen atom. So carbon is going to carry 4 hydrogens surrounding it. So it has got maximum. Or that maximum means what? Every bond is linked. Every bond is linked to hydrogen atom. Every bond from carbon is linked to hydrogen atom. So this means the carbon is saturated. The carbon is saturated. Saturated means it has got maximum number of hydrogen atoms bonded to carbon atom. That's what we call hydrocarbon. Hydrocarbon. So I want to check on the sources of alkanes. Sources of alkanes. Of course, I've already said that alkane is a single bonded. It has got a single. Okay, what I mean by single bond is carbon to carbon bond, because it can form a chain. It can form a chain of alkane, so it can link carbon to carbon. So a single bond is used to link one carbon to another carbon. So that's what you mean. And the alkane is a hydrocarbon bonded by single covalent bonding. So I want to move to sources of alkanes. Sources of alkanes. The source of alkanes we have here, alkane can occur naturally as methane, as a mixture of methane gas. One of the sources of alkane is it can occur naturally as methane gas. In Form 1, you studied about the air. Air is a mixture of gases, whereby you did fractional distillation of liquid air, whereby you got fractions of air, whereby methane and other gases like propane and butane were among them. So I want to talk about these gases. So this methane is one of the alkane, because alkane ends with A and E. So every word of alkane compound will end with A and E. So we have methane as a gas, ethane as a gas, and propane as a gas, and finally we have butane as a gas. So those gases occur naturally. They occur naturally. That's the source. That's one of the sources of alkanes. I want to move to chief producer of alkane is crude oil. Another chief producer of alkane is crude oil. Crude oil in Kenya, I said it's extracted in West Pokot. While in a class we discussed about this. So it is when it is extracted, it can't be used directly, but it has to be transported to the industry to get separated. So because crude oil is a component, it contains fractions of alkane compounds. So it has to be transported to the industry to enhance separation. Because after extraction, you can't use it directly. So in Kenya, it is transported to Changamwe, Mombasa, where yes,
Victor, please allow me to interrupt you for a minute.
Yeah.
I have tried to message them privately, but seems like Salma and I'm guessing Nadifa please adhere to the instructions and stay on camera properly. Otherwise, you will risk being removed from class. Salma Ali, and I'm guessing it is Nadifo, stay on camera properly. Sorry, Malim.
Okay, thank you. I want to move on by saying that we have crude oil. Crude oil is a chief producer of alkanes. It's the chief producer of alkane. So this crude oil extracted from the underground, and since it is extracted, it can't be used directly. It has to be transported for further refinery. So it is transported to Mombasa, Changamwe industry that separates all of these fractions. So what I mean the fractions here, we have alkane, alkenes are there, alkynes are there, we have petrols are there, we have diesel, we have naphtha, we have bitumen, all are fractions from crude oil. So that's why we are saying that after extractions, it can't be used directly. It has to be transported to Jangam, Mombasa to get separated. So crude oil is the chief producer of alkanes. So let us look at how this method works. So how is this method works to separate these components of crude oil? So after transportation to the industry, the fractions are separated based on the method called fractional distillation. In Form 1, you start about fractional distillation, yes, whereby you separated water from, you separated the ethanol from water. And this was achieved because water and ethanol have different boiling points. So when the boiling points of ethanol is reached at 78, you tap off ethanols, and then you remain with water, which boils at 100 degrees. So I want to come back to fractional distillation again here. This fractional distillation works on the principle that different fractions of crude oil contains different boiling points. Because refinery gas, petrol, diesel, and all those bitumen, including kerosene, contain different boiling points. So fractional distillation comes in to enhance separation. This is the method used to separate the crude oil because it works on the principle that all fractions contains different fractions. Different boiling points. Now, what are these fractions? Because this is not mathematics. It's not maths, but I'm talking about fractions from crude oil. Fractions, I mean, here we have the components of crude oil. What makes up crude oil? So we have refinery gas. So if the temperature reaches 25 degrees, that is below 25 degrees, they tap off what we call refinery gas. This one already you have it down. They tap off what we call refinery gas. So this refinery gas is very important. You know the use of a gas, okay? So below 25 degrees, they get the refinery gas. So since you know the use of a gas, I will ask one of you to say one use of a gas. One use of a gas, because even in your homes you are using gases. So who can tell me the use of gases that you normally come across, even around your environment? Who can say? We have Suleiman Abdinasir. Can you say the use of a gas? Yes. Suleiman Abdinasir, please.
It's used for cooking.
Used for cooking, very important. It is one of the uses of refinery gas. Another one? Another use of this gas, refinery gas? Okay, someone else can answer, Zubeya? Okay, it's also used in laboratory gas. It's used as a laboratory gas. When you go to the lab, there is a gas that burns that help us to boil some of the reagents in the lab. So this gas is the one that's used there, the laboratory uses. Okay, so it has got domestic use and laboratory use. So that is under 25 degrees Celsius. When you move to 40 to 100 degrees Celsius, 40 to 100 degrees Celsius, 40 to 100 degrees Celsius, you get what do you get on your notes? That is 40 degree to 100 degrees Celsius. What do you get on that? You get the petrol, that is 40 to 100 degrees Celsius. Under 40 to 100 degrees Celsius, you get petrol. Who can say the use of petrol here? I've said below 40 to 100 degrees Celsius, you obtain petrol. What's the use of petrol here? The weather, Hussein? Use of petrol. Are you getting me?
Mwalimu, whom did you ask the question?
I'm asking the uses of petrol because we have said that under 40 to 100 degrees Celsius, you are going to obtain petrol. So between 40 and 100 degrees Celsius, you are going to obtain petrol. So what is the use of this petrol?
Which student did you ask, Mwalimu, so that I can allow them to speak?
I asked Luweda Hussein. Luweda Hussein, please.
Running vehicle engines.
Running vehicle engines, yeah. It's a general term, running vehicle engines, but not all engines that use petrol. Because, yeah, I know it's running vehicle engines, but not all engines use petrol, others uses diesel. Not all vehicles uses petrol, but others uses diesel. So we have petrol engine and we have diesel engine. So let's move to 90 degree, between 90 degree and 150 degree, we will have another fraction. We will have another fraction between 90 degree and 150 degree. We will have another fraction, and this fraction we call it the naphtha. We call it the naphtha. Naphtha is used to make varnish. Remember the varnish used to make beds beautiful, to varnish chairs. Varnish. We call it. It is tapped off when the temperature is between 90 and 150 degrees Celsius. You get a varnish. Okay. You get what we call a naphtha. Naphtha is used to make varnish. Varnish is the one you normally use to make chairs beautiful, to varnish chairs, beds, yeah, those things. So another temperature is when you have the temperature of around 150, between 150 and 240, you will have kerosene. You will have kerosene. Kerosene is another fraction of crude oil. Kerosene is another fraction of crude oil. So what is the use of kerosene here? Kerosene, Supeya, please give us the use of kerosene here. Kerosene. Zubeya Abdi Nasir, you don't know the use of kerosene? Kerosene is another fraction of crude oil. So what's the use of kerosene? Salim Ali, tell us that. Uses of kerosene. Yes? Are you getting me? Uses of kerosene. Okay, the use of kerosene here is it is used domestically as a you have stoves. Okay, it's used for cooking. Kerosene can't be used to run engines, please. Kerosene is used for cooking at home. Some families normally use kerosene to cook food. Kerosene is put in stoves so that it can produce heat. Okay, that's the use of kerosene. And between this one is obtained when the temperature is between 150 and 240 degrees Celsius. So if you have the temperature of 250, between 250 and 300, between 250 and 300 degrees Celsius, we will get what we call fuel. I mean, I'm sorry, we will get what we call diesel. That is a temperature between 250 and around 300 degrees Celsius. So you will get what we call diesel. So what's the work of the diesel here? Who can give us the answer? Uses of diesel. Hassan Abdullah, diesel. Hassan, diesel. Yes. Diesel. Okay, I can see two brothers, Muhasin Shafi and Hassan Ahmed. Please give us the use of diesel.
Fuel for diesel engines.
Yes.
It's
Very good. It is used to run.
For diesel engines.
Yeah, that's good. Yeah, correct. It is used to run diesel engines. As I said earlier, that we have petrol engine and we have diesel engine. So it is used to run diesel engines. Okay, so that's the work of diesel. So the temperature of around 350 and 355, we will have what you call lubricating oil. Lubricating oil. Lubricating oil. So lubricating oil is used to reduce frictions on the moving parts because it's used as a lubricant. That is a degree of around 350, 355 up to around 400. You will have what we call bitumen. Bitumen is a dark substance used on road tarmacking or used on road construction. Bitumen. Bitumen is another fraction from crude oil that is used to construct roads or used in road construction. We call it bitumen. These substances are very important because they are fractions of crude oil. So when crude oil, when all these have been achieved by fractional distillation, therefore, all this one will be transported from the industry to the points where they can be sold. For example, petrol is transported to the petrol stations. I know you are drivers, most of you. Diesel is transported to the petrol stations again, whereby it is used to where people used to refill their engines so that vehicles can work well. So these are some of the fractions that are obtained from crude oil. So they are now able, you can now use them because now they are separated. Now, I want to move to another part that is very important. Unless you have a question, you can ask on the same. If you have a question, you can ask on the same, on the foreground discussion. If you have a question, you can raise up your hand. So I want to move to what we call cracking of alkanes. Cracking of alkanes. Cracking of alkanes. What is this? Okay, I want to use an example here. If you have a long chain, because later we will see how these chains are. Chains of alkanes are very long. So if you have a long chain of alkane, this long chain is of less demand to the market. This long chain is of less demand to the market. So what happens is that it's like when you grow sugarcane at home. Some of the farmers normally cut the sugarcane into pieces so that they can sell them well, so that to obtain much profit. So I'm using the example of sugarcane to explain it here. So if you have a long chain alkane, this long chain is of less demand. So to make supply of more demand of these alkanes, you have to break it down. You have to break the long chain down to shorter one. Okay? Break the long chain hydrocarbon down to shorter one. This breakdown of long chain hydrocarbon to shorter one is what we call cracking. Cracking. You reduce in size. If it is too long, you reduce it in size so that you can make it of more demand to the people, of more demand to be used in various industries. So if the chain is too long, later we'll see what I mean by this long. Okay, if the chain is too long, this longness is of less demand. You have to make it short. For you to attain this one, you have to use the method they call cracking. You have to crack it down. So how can you achieve this? Methods of cracking. Methods of cracking. These methods of cracking, we have thermal cracking, and we have another one. Who can I say the other one? One of it, we have thermal cracking. Who can I say the other one? Zamzam. Zamzam say. The first one is thermal crack, methods of cracking. We have one is thermal cracking. Another one is what? Zamzam, tell us. Yes. Zamzam Abdullah. Yes. I'm repeating the question. I'm saying we have methods of cracking. All types of cracking. We have. Yes.
I don't know, teacher.
I'm saying one of the methods of cracking we have is thermal cracking. Thermal cracking. There are two. What do you call the other one? Yes.
I don't know.
Don't know. Fatuma Mo Awil. Yes.
Catalytic cracking.
Correct. We have
Catalytic cracking.
Correct. We have catalytic cracking. The first one is thermal cracking. Another one is catalytic cracking. So I want to talk about Are you getting what I'm saying? We have thermal cracking and we have catalytic cracking. Those are the types of cracking. Catalytic cracking and the thermal cracking. So thermal, let us discuss shortly about thermal cracking. Thermal means heat. Thermal is heat. You have to apply heat. Okay? You apply heat. So the heat here must be too much. The heat here must be too high. That is around 600 and 700 degrees Celsius. So 600 and 700 degrees Celsius is a very high temperature. So we call it thermal cracking. Thermal cracking means you irradiate the long chain hydrocarbon to shorter one. So when you break down a long chain alkane, what do you obtain? For example, you have CH3, CH3, CH2, CH3. I repeat, for example, you have CH3, CH2, CH3. This CH3, CH2, CH3, we call it propane. That's a propane compound. So this propane, if you subject it to a temperature of 600 and 700, between 600 and 700 degrees Celsius, you will obtain methane, which is CH4. You will obtain methane, or what we call ethene, which is CH2 double bond CH2 plus propene. Another one is CH2, CH3, CH2. That is propene plus hydrogen gas. So in short, what I'm saying here, when you break down long chain alkane, you obtain an alkane, and hydrogen gas. I repeat, when you break down a long chain hydrocarbon on alkane, you obtain an alkene when you subject propene to a temperature of 600 and 700 degrees Celsius, what do you obtain? You get which is CH4. You get ethene, which is CH2, double bond, CH2, propene plus propene, which is CH3, CH2, then plus hydrogen gas. That is okay. Because you have notes, you can follow that. That is when you break down a long chain hydrocarbon, or what you when you break down a long chain alkane to shorter chains. So what I mean here is that methane is of high demand than propane. Methane is of high demand than propane. Another important point I want to note here is this: that cracking is the main source of hydrogen gas. Cracking is one of the major source of hydrogen gas. Industrial processes. For example, in the industry that manufacture ammonia, what we call HABA process. Okay, this one we will discuss later. It's a topic of its own that is ahead of us. So if you have HABA process is the industry that manufacture ammonia. So ammonia is a reaction of hydrogen and so hydrogen used here is obtained from cracking. Cracking is one of the source of hydrogen gas because at the end of the equation there's hydrogen gas. This hydrogen gas obtained here is not a okay. I want to move to catalytic cracking. Catalytic cracking. Catalytic cracking is the you subject the a long chain hydrocarbon or a long chain alkane to temperature, but in presence of a catalyst. I repeat, this catalytic cracking means you subject a long chain alkane to a short to a low temperature. This temperature is low. It's not too high as thermal cracking. The temperature is low, but in the presence of a catalyst. Okay, I want to ask a simple question here. I think it's simple because most of you know it. What is the function of a catalyst? What's the work of a catalyst? Because now you are in Form 3. Now you are in Form 3. You know the catalyst. In Form 1, you studied about manufacture of oxygen gas, where you used what was the work of okay, where you used manganese oxide. So what was the work of manganese oxide there was to okay. I don't because if I say the work of manganese oxide, I would have given me the work of the catalyst. So what is the function of a catalyst? What's the work of a catalyst? Who can tell us the work of a catalyst? Omar Sayan, give us the work of a catalyst. Catalyst? I can't hear you.
Whom did you ask the question, Mwalimu?
I asked the Omar Soyan. Catalyst.
To speed
What's the function of
the chemical reaction?
Very correct. It speeds up the chemical reaction that remains unchanged at the end of the. Yeah, I have heard you. The work of a catalyst is to speed up the rate of chemical reaction, but it remains unchanged at the end of the equation, at the end of the reaction. So that's the work of the catalyst. So here, I mean here on the cracking of crude oil. I mean I'm on the cracking of long chain alkane. So you will see that the work of the catalyst will speed up the breakdown of propane to methane, ethene, propene, and hydrogen gas. But at the end of the reaction, it will remain unchanged. If the catalyst used here is 2 grams, at the end of the reaction, it will remain being 2 grams because it remains unchanged. So that is the work of the catalyst. It speeds up the chemical reaction because it speeds up chemical processes to take place. So for you to obtain the methane in the least time possible, you use nickel catalyst. The catalyst used here is nickel catalyst. nickel catalyst. Nickel is a transition element. Is a transition element that has got a very crucial importance on speeding up the chemical. I mean, on speeding up the rate at which chemical reaction occur. So this catalytic cracking involves the use of a catalyst that is nickel and a low temperature So up to this point, I wish to ask some questions here. I wish to ask some questions here that are very important. So I wish to ask some questions here that are very, very important. We have for the first one is, want to have some revision questions on our discussions. Revision questions on our discussions. We have number 1A. I wish you write. I wish you write. Write somewhere. Write somewhere. I wish you write. Okay. Number 1A. Say, define the following terms. Define the following terms. Define the following terms. Define the following terms. I wish you write. Define the following terms. That's number 1A. Define the following terms. Roman 1. That's number 1A, Roman 1. Hydrocarbon. Hydrocarbon. I repeat. This we want to look at the revision. We have to do some revision on the discussions, our discussions. Number 1A, we have define the following terms. A, Roman 1.
Walimu, excuse me.
Yes, sir.
Yes, Walimu, we have those questions. You have already sent them.
Oh, you have already. Okay, that's good. That's nice. That's nice.
Those
okay.
questions,
Okay.
we already have them.
Yeah, okay. That's good. So let's who can define for us hydrocarbon? A, Roman 1. Hydrocarbon. What is hydrocarbon? As used in organic chemistry. Hydrocarbon. Roman 1 is hydrocarbon. Who can define this for us? Iron. Iron, give us the definition of the word hydrocarbon. Iron, give us the definition of the word hydrocarbon, because we had already discussed this one. Hydrocarbon. Okay, somebody else to say this? Hydrocarbon. I said that hydrocarbons are compounds that are made up of hydrogen and carbon only. There are compounds that are made up of hydrogen and carbon only. We call them hydrocarbon. Is everyone okay there? Hydrocarbons are compounds that are made up of carbon and hydrogen only. Roman 2, we have saturated hydrocarbon. Saturated hydrocarbon. Saturated hydrocarbon. So I want to select somebody to do it. Abdiwadud Mukhtar, please give us the definition of saturated hydrocarbon. Abdiwadud.
Saturated hydrocarbon.
Yes.
Are the alkane carbons that contain maximum number of atoms bonded to the atom.
Yeah, that's good. These are the hydrocarbons. It contains maximum number of hydrogen atoms, possibly bonded to carbon atoms. That's what they call hydrocarbons. So I want to do just number 1, then number 2 you will do alone. Number 1B, state the condition necessary for thermocracking to take place. State the condition necessary for thermocracking to take place. State the condition necessary for thermocracking to take place. Who can answer this? Hey, Carl. Hey, Carl. Condition necessary for thermocracking to take place. Yes? Hey, Carl Abdiwal.
Heikal seems to be experiencing some difficulty in picking up the audio.
Okay, when you are talking about condition, we mean this. What makes the long chain hydrocarbon to be broken down to the shorter ones? So what we mean here is condition is what makes the longer chain hydrocarbon to be broken down to methane, ethene, propene, and hydrogen gas. So what makes this one to be achieved is temperature of 600 and 700 degrees Celsius. That is the condition. The condition is either you say heat or temperature of 600 and 700 degrees Celsius. That's the condition necessary for thermocracking to take place. Condition necessary for thermocracking to take place. So we say it is temperature of 600 and 700 degrees Celsius, or heat. Heat is the condition necessary for thermocracking to take place. So I wish to stop there for our discussion. So you will be doing number 2, then we shall start from there tomorrow. Thank you.
Hello.
Thank you so much, Mr. Victor.
I'm saying if
Form
you're doing
3
physics in the afternoon, let's just say that you prepare your midterm paper.
Form 3's your physics teacher is instructing you to come with your midterm examination papers and be ready with them for the afternoon class. Prepare for the physics afternoon class with your midterm examination papers.